Audio plugin software development might seem like black magic to some, at least in part because of the lack of well-defined standards and the scarcity of how-to information. The difficulties of writing a plugin host are not far behind. In practical terms, Steinberg's VST API provides a form of standard or a set of requirements that plugin developers are expected to follow. But the documentation, I think, has something to be desired, and it is perhaps not surprising that ambiguities exist, and sometimes one has to resort to trial and error when trying to interface with a plugin. And of course, plugin developers don't always supply technical documentation with their products. Nevertheless, writing a VST plugin host application can still be fun and satisfying, and in these videos I'd like to show you how I do it. My solution is not necessarily the best, so anyone with expertise in this subject is welcome to share his knowledge with us in the comments. However, to be clear, I know that there are various frameworks out there that could be used, but my specific aim with this is to write all the code by myself, apart from Steinberg's VST API, of course. That API will provide the glue between the host executable and the plugin. I'd like to start by laying down my goals, and they look like this. I want to write a simple VSTi plugin host application in C++. Notice the I, since I'm focusing on hosting plugins that are instruments. In other words, ones that generate sound. And to begin with, I want to display some information about the plugin, such as the vendor's name, the number of channels, and the various capabilities the plugin has. Things like that. Then I want to be able to read a standard MIDI file and send MIDI events data, essentially note on and note off messages, to the plugin and get back audio data. My program will save these data in a WAV file in the required format. Not only that, but the program will interface with the computer's audio driver and play the audio. I also want to display the plugin's editor GUI, if it has one, that is. Finally, I want to be able to play the plugin in real time from the computer keyboard. Before we go any further, let me bring your attention to the description under the videos. Always check the description, please, because it might contain important additional information and updates. The thing is that I can't edit the video once it's published, so if I need to add something or correct something, I can only do it in the description. Also, by now you can tell that English is not my mother tongue. I do have a strong accent, so if you find it difficult to understand what I'm saying, try to turn on the subtitles. Hopefully, YouTube will generate a transcript of my speech. Now, I would like to talk about the software development environment I will be using in this project and the software tools we will need. I'm on the Windows platform, but much of the C++ code will be the same if you are on Linux or on the Mac. The Windows-specific stuff comes in when we interface with the audio driver or display things on the GUI. But even then, the equivalent methods and interfaces could, I'm sure, be easily found on those other platforms. For program development, I will be using Visual Studio 2019 Community Edition, which is free to download from Microsoft. Registration is required, but it is also free. Then we need the Steinberg VST API. I know it is a controversial topic, but for this project I will stick with the old and discontinued version 2.4 of the API. The reason being that it is easier to understand and work with, and most of the plugins that are out there floating around on the internet have been written with version 2. The newer version 3 plugins typically cost money, but the older ones are often free. So this is what the directory structure looks like after you downloaded and installed the SDK. Take a look at the documentation. As I said before, it's lacking detail, could have been done better, but it does have some useful bits. If you are new to VST plugin programming, as I think you would be, because this video is targeted to those who are just starting out, Then I suggest you begin by reading the introduction. And then there is a good section on the most basic forms of communication between the plugin and its host. See, these diagrams briefly sketch out the plugin's lifecycle. I also suggest to look at the .h files, where you find the function declarations, constants, various data structures, and the so-called opcodes. This is probably the place you will come back to most often during development. These opcodes will be our friend when we start writing code because they play a major role in the interaction between the host, or audio master in Steinberg's terminology, and the plugin. As for the rest, well, you could spend a lot of time searching through the class hierarchy and get really frustrated because it is not much more than a list of objects and methods without a description that would tell you what they do and when and how to use them. Before we get our hands dirty with coding, there is one more important task that will also prove to be very useful, namely to look at some of the samples that came with the SDK. Under the Win folder, or the Mac folder if you are on the Mac, you'll find a Visual Studio solution file. Click on that to open the sample projects in Visual Studio. There are two projects we will be interested in: VSTi Synth, which is a plugin, and MiniHost, which of course is a plugin host executable program. Build these two. Don't try to build the entire solution. It will probably fail. Once you're done, set MiniHost as your startup project. And then just edit the MiniHost file so that it will work with the VSTi Synth plugin. Now let's build and run the project, and if everything goes well, we get this output. I remember getting an error on first try, but I forgot what it was. I think it was to do with this flag here. What I want to do next is to take a look at the source code in these samples. But before we do that, here is this diagram that will help us understand what is going on. If I just showed you the source code straight away, we would probably get lost among the many lines of code that are not important for our purposes, and it would just blur the picture. So here we have the host on the left-hand side and the plugin on the right. The plugin is essentially a dynamic link library, so in the host we begin by loading that library into the memory space of our executable. And then we need to get an entry into the DLL. And the standard says that the entry point or address should be called VST plugin main. With that entry point, we are now able to set up a communication channel between the host and the plugin. The plugin can talk to the host via a callback function, and the host gets access to the plugin's methods through this effect object. In the host, we will have a pointer to this object. One of the members of that object is the dispatcher, which is a function through which the host can instruct the plugin to execute one of its methods. This here is a call into the plugin. Effect here is this pointer to the effect object, and the opcode attribute tells the plugin which of these methods we want to execute. The values of these other four attributes will depend on which function we are calling. Okay, so it is time to jump into the source code, and we'll begin where the application starts, namely the main function in minihost. As you can see, the dynamic link library is loaded here, and we obtain the address of the main procedure here. Now, in some older plugins, we can find that the main procedure was called main before the standards were fully established, but in version 2.4 it is VST plugin main. Here, the callback routine between the plugin and the host is set up, and we get a pointer to the effect object of the plugin. Effect is actually a struct in the VST API. Here you can see the dispatcher and some procedures and properties. Down here is an example of a call into the plugin through the dispatcher. And here this is a local method which again makes calls to the plugin through the dispatcher. For instance, this gets the VST plugin vendor's name. And this one simulates a core function, actually the most important function of the plugin, where inputs are converted into outputs, and we will talk about this one a lot in the future. At the end, we close the plugin. Now let's take a peek into the plugin. VSTx synth is defined here. This is the constructor, and as you can see, it is subclassed from audio effect X. Well, with this we are already in the Steinberg API. Audio effect X is in turn subclassed from audio effect. I won't go into that one, but this just shows how Steinberg extended their API as the software grew in sophistication. And here you can see the dispatcher at work. The actual processing is in this module here. The function process events is where incoming MIDI messages are dealt with. It is processing note on and note off messages. Up here, process replacing is the place where sound data is generated. And it is then the host's job to do something with that sound data. Are you ready to get your hands dirty with coding? Then let's create a project for a C++ console application. I call it Simple VST Host. Get rid of this Hello World stuff that Visual Studio puts here. We won't need it. What we will need, however, is some interface definition files from the VST SDK, so copy them over to your project folder. Once that's done, we need to include them in the project. Lastly, some of these files include other files, and the include paths are now out of whack, so fix those. In this very first version of the simple VST host program, we will write code to basically do something similar that we've seen in minihost. Load the plugin, write code which is to do with the plugin's lifecycle, such as opening, initializing, activating, closing. This is basic but essential stuff that needs to be executed every time the plugin is used. The more interesting bit comes when we ask the plugin for bits of information and show that information on the console. In this first video, this is more than enough. Even these first few steps can be tricky. I'm not going to waste your time by typing out the code in real time, but instead show you what I've got already and explain. As you can see here, I have a plugin class which encapsulates the interface to the plugin. This is the constructor with a parameter that's a pointer to the plugin's effect object, and we've seen this before on the diagram. These methods are to do with opening and closing the plugin. Suspend means stopping processing, and that needs to be done before we are allowed to change the values of certain properties of the plugin. As you would expect, resume is the opposite. It means putting the plugin into a state where it is ready for processing. In these methods, we will ask the plugin for various bits of information and display that information on the console. Now, before looking at the implementation of these methods, let's examine the main function, which is here. What you see here should look familiar because we've seen something like this in minihost. The dynamic link library is loaded here, and then we get an entry point to the DLL. On this line, a couple of things are happening. A callback is set up from the plugin to our host. The callback is declared here, and the definition is here. We will look at that later. Now back on this line, a plugin object is created. Here, the effect pointer is assigned to a local variable, and then this method is executed, which contains an important test. If this so-called magic number is incorrect, then something seriously went wrong and we can't continue. Further down, we assign a pointer to the dispatcher to a local variable. This is just to make function calls into the plugin simpler. Now let's look at the function implementations in the plugin. In Open, the plugin is opened and initialized by assigning values to some fundamental properties, and then resume is called. This is to put the plugin into ready state for processing. Resume itself is very simple, as you can see, and of course suspend is just the opposite of resume. Before we close the plugin, we call suspend and then close. And here comes the interesting bit, where we obtain some information from the plugin and display it. But I won't go through this in detail. This source code will be available to you to download and read later. I just want to point out that there is another way to call functions in the plugin other than going through the dispatcher. You can call functions directly. First you obtain a pointer to the audio effect X object, as you can see here, and then you execute its public methods, like here. Okay, so that's that. And now, jumping back to the main function. I haven't covered the host callback function yet, have I? It is actually very important, as we will see later on, but for now I kept it simple and it only handles a few opcodes. There are a lot more than these, and some plugins won't work properly if certain callbacks are not handled. And to find out which ones is a bit of a guesswork. To finish off, the plugin is closed and the DLL is freed. And now comes the moment of truth. Let's run the program. The output looks eerily similar to what we've seen in minihost, but that could be expected, I suppose. So far it was easy, wasn't it? But I can assure you it will get a lot more difficult later on. In the next video, we will start doing MIDI input processing. So see you then.